Okay guys, today I'm going to talk about dimensional analysis. So this is a really important lecture. I'm going to talk about dimensional analysis over a couple of videos just to kind of break it up and go incrementally more intensive. Really, dimensional analysis, a lot of times people think of conversion factors, conversion factors are correct, but a lot of times people think of unit conversions, which is really just one application of dimensional analysis. Dimensional analysis is actually a problem-solving technique that we're going to use all throughout the quarter. So I can't stress enough that it is very critical that you really get this down and you understand how to do dimensional analysis. This will help you throughout the quarter. This will be invaluable to understanding things later on. So I guess dimensional analysis, the way to think about it, is it's a problem-solving method where we use the units to guide us in setting up calculations. So we don't have to guess when we do a conversion factor. If I have, 48 inches and I know that there are 12 inches in a foot, using dimensional analysis, I don't have to guess. I'm obviously either going to be multiplying or dividing by 12, but dimensional analysis tells me which of those it is. Like, I don't have to guess. I can figure it out by looking at the units, and we'll talk about that. So remember that units can be multiplied, divided, and canceled just as any variable. And I talked about this in the unit conversions, or the conversion factors lecture. So you've forgotten that, you've forgotten how to write conversion factors, you need to go back and watch the video. That's critical to understanding how to do dimensional analysis. So it's not only used in unit conversions, we can use it in lots of other types of problems. So we're first going to practice this in unit conversions, but we're going to then expand it. So it's really, really straightforward on how to solve this kind of problem. So consider this problem. I've got a vitamin C tablet with 500 grams. I want to know how many milligrams it contains. So the way I'm going to start with this is you're just going to start with the number that you know. And you always want to start with some value you know just here. So 500 grams. Now, my goal is to try to convert this into milligrams, but I don't want to change what the value of it is. I want to keep the same meaning or the same numerical value, but I just want it in milligrams now. So what I'm going to do is I'm going to build what's called a conversion factor, and we talked about this in the last video. So I'm going to build a conversion factor. Now, my conversion factor is going to be between grams and milligrams. So you remember how we do this in what I talked about in the last video was how to build a conversion factor between grams and milligrams. Now, here's how I do this sort of in the problem. Remember, a conversion factor has to have the same, whatever's in the numerator and whatever's in the denominator have to be equal. So I need some relationship between milligrams and grams. But what we're going to do in dimensional analysis, and this is why it's so critical to write your units as you're doing a problem. I now know what's going to go where because I need grams to cancel out. So I want grams to go down here in the bottom, and I want milligrams up on top. All that's left for me now, so you always see me do this, you always want to put in the units before you put in the numbers. So now, what I'm going to do is I'm going to write the numbers. So remember, I always put a 1, do you remember where I always put the 1? In front of the prefix, and the prefix is the milli in this case. So right, there's grams and grams, but this is milligrams that has a prefix. 1, and then I put the definition of the prefix down here, and that gives us a conversion factor because milli already means 10 to the negative 3. So now the numerator equals the denominator because 1 times 10 to the negative 3 grams equals 10 to the negative 3 grams, right? Makes sense. So now I'm going to do my math, and this is going to be 0.5 divided by 10 to the negative 3. Right? So anything that's on the denominator you divide by. So it ends up being 500. But now we have to pay attention to significant figures, right? So how many significant figures does my conversion factor have? Hopefully you said unlimited or infinite. It's an exact conversion factor because it's metric to metric. I'm then therefore limited to my 3 significant figures I have here. So appropriate answers will be 500 with a decimal point milligrams or 5.00 times 10 to the 2 milligrams. Either one is fine. So hopefully that makes sense. So we can do I'm going to do another example of the same. So let's say I know that there are 5,280 feet. So my point is we can do this with any, I'm going to do a couple examples here. We can do this with any conversion factor, either metric, English, 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 metric, metric, whatever. The only ones I'm expecting you to have memorized are those ones involving the metric conversions, or the metric prefixes. Something like this you'll be given, but I'm going to talk about how to make a conversion factor out of this. So let's say I want to know how far a 10-kilometer run is, right? Wait, that's not good. That doesn't match up with what I gave you. I want to know how many feet 6.8 miles is, right? So 6.8 miles, I'm going to put miles down here, right? Because I want it to cancel. So I want this to cancel this out, and then I put feet up here. And then all I have to do is put the appropriate numbers here. So 5,000, 280, and 1. So this is why this is called dimensional analysis. The units tell me where the numbers go. So I can't stress this enough. This is why you absolutely need to be writing your units in your problems, because otherwise, how do you know what you're doing? How do you know what multiplies by what and what to cancel? So my answer is, of course, going to be in feet, because that's the only unit that's left. And if I take 5,280 times 6.8, I get 35904. How many significant figures should I have here? Hopefully you said 2. This is, again, unlimited because these are both English units. So this is just going to be 2. So this is going to be 36,000 feet. There we go. Okay, so I'm going to do one more practice. Let's do 6.8 times 10 to the 4th micrograms. Actually, no, let's do nanograms just for fun. Nanograms to grams, right? Okay, so remember I said it's important to know where when you build these metric unit conversions, where the 1 goes. The 1 does not always go on the bottom or the top. The 1 goes with the prefix, right? And I knew to put nanograms down here so it will cancel and leave me grams. 1 nanogram is 10 to the negative 9, because that's what nano means. Nano means 10 to the negative 9. So that gives me, and now here's something kind of neat. Because this is already in scientific notation, what I really have here is 6.8 times 10 to the 4th times 10 to the negative 9. And remember, if you have 10 to the x times 10 to the y, it's really 10 to the x plus y. So what I've got is 6.8 times 10 to the 4 minus 9, which is negative 5 grams. So this is why the metric system is really easy to work with, because you're just working with these powers of 10. So I'm going to do one more, and then I'm going to call it for this video. And I'll start another video to do multiple step dimensional analysis. So just taking this one step at a time. So let's do, and remember, these prefixes work no matter what kind of unit you're using. So let's do 1.45 megaliters to liters. All right? So megaliters to liters. So megaliters goes down here. Liters, 1. Do you guys remember what mega means? Mega is 10 to the 6th. So then I get 1.45 times 10 to the 6th liters is what that is. So hopefully that all makes sense.